any luck, this will only take us, come on guys, with any luck, this should only take us about 15 minutes or so to go through the last few examples in section 8.6 and then allow us a little bit of time to get some work done. We are well ahead of the pace that I figured we'd be at by this point in time in this chapter, but I am not going to push the test any faster. No big deal. We're still going to test next Thursday. That's going to allow us to be able to spend some time working with the two different types of exponential growth modeling sections that are in here. Originally, I was just going to worry about one of them. Now we'll be able to do both. And then it'll give us time still to have at least probably about a day and a half of Q&A review stuff. I will have some review problems and everything ready for you guys next week. I'll probably get that to you maybe Monday. I'll make it up over the weekend. But yeah, that way we'll finish out of chapter 8 on that Thursday over before that 4-day weekend and just call it, and then we'll get into trig. It's very exciting. Yes, sir? Yeah, that's fine. Thanks. All right, let's take a look at the, yes, sir? Yeah. Yeah. Log equations. So again, I'm not going to worry about all the words because I bet you if you look at this, you're going to tell me exactly what you have to do to solve this log equation.
Possibly.
In order to solve this log equation, what do you think you have to do? Yes, sir. No.
Minus.
Yes, ma'am. It's exactly what you do. Ladies and gentlemen, notice how the log base 3 is the same thing on both sides. If the log base 3 is the same thing on both sides, what happens? They basically drop themselves out. Because what you are in essence doing, you're exponentiating both sides to the same base. When you do that, you get 5x minus 1 is x plus 7. Variables on both sides of the equation, what do? You pick on the little guy. Now, what should you check real quick? Yeah, just substitute in real fast. And this is a very easy one to look at because what's 5 times 2? What's 10 minus 1? So this is log base 3 of 9, which is log base 3 of 3 squared, which is 2, correct? All right. What's 2 plus 7? The same thing? It works. Again, take a brief second to double check, make sure your answers do work because there will be times that they don't. Yes, sir. Oh, I thought you had a question. Sorry. All right. Oh, I forgot I had this one here. Nope, I had it on the next page. Never mind. Log base 2 of x plus 2 equals log base 2 of x squared. Again, what happens? Yes, sir. Yes, that's exactly what you do. Again, do these guys have the same exact log base? Okay, so what would I be exponentiating them to? Do I have to write that? Okay, so I have x plus 2 is x squared. Set aside equal to 0. Oh. A lot of you guys are probably looking at it, they go, oh, it's going to be 2, because 2 plus 2 is 4, and 2 squared is 4. You have to factor. Your possible zeros then are 2 and negative 1, which means you have to double check them. Again, this one's pretty simple to double check with the 2, because what's 2 plus 2? What's 2 squared? 4. That one works, right? Yeah. Okay. What's negative 1 and 2? 1. What's negative 1 squared? Does that one work? No. They both work. Again, there will be times when you have factoring problems and you get one of them to work, both of them to work, or none of them to work. It is completely, totally possible. What's that, Willis?
What? I don't know how you possible for anything to work like it. And it's possible.
It's true. All right. Okay. You don't need to do this. Let's exponentiate again. Let's worry about exponentiating, not flat permeating.
Yeah, because that bird, that's for sure. Not right there.
No, I don't care.
Oh my God.
What kind of persuasive patience required?
Log base 5 of 3x plus 1 equals 2. Again, in this case here, I need to get rid of that log base 5. What do?
And put a log 5 on the other side?
Not a log 5, I'm exponentiating here. What I want to do is I'm using the property of log base b of b to the x, or b to the log base b of x. I got to put this exponentiate thing. What I'm doing here is I'm putting a 5 below it. And that means I have this over here. What happens now is since you have log to the log base 5, since these two guys are the same, that's how it drops out. You get 3x plus 1 is 25. Okay, you get 3x. X is 8. Very good. Again, what you're doing is exponentiating. When you have a singular log, what you'll have to do is just basically use that base of the log as the new base, and the problem becomes an exponent. That's why they call it exponentiating. Really isn't that bad, is it? Okay. Then try this one. Bless you. What's your first step going to be here, guys? Subtracting 15, good. So now we have 2 of log base 2 of x is 16.
I think I just got it.
What do you do, Willis?
You would, maybe I'm wrong.
No, tell me, what are you going to do?
You would put the 2 above the x.
No. You're thinking about expanding or condensing here.
You don't do that?
You don't have to do this in this problem.
Well, okay, well then wouldn't that 2 and that 2 cancel out?
Not this direction.
Oh, wait, what?
Yes, it's true. Completely terrible. X equals
2 to the 8th is what?
256.
You're thinking, yeah, you did the other way around. Yes, this is 256. Okay. Now, Willis, what you were saying is if you went to log base 2 of x squared, you're right. That is how you would set up that problem. And that would have equaled 16.
Right,
Now, you could still exponentiate that, right?
right, and then just,
So you get x squared is 2 to the 16th power.
No one knows.
65,000.
add another 5.
And then what's the square root of that?
Oh my gosh.
It would have worked.
Maybe.
It would have worked, Melissa. That would have been just fine. Okay. What you're using is you're using the properties of condensing and expanding, like we were talking about the past couple of days.
Right.
All right, so you paid attention.
I mean,
How did you get 2 log 2 x equals
Here.
8 over 2 and then x equals 256?
This is 2 log, what I did is the exponentiate here. So this is 2 to the 8th power. And that's where this came from. All right? But yeah, your way is just fine. That would work just fine.
Let's get on this.
Yes, sir.
no.
No. I will show you my prom picture when prom comes around. How's that?
Really? Murph? You went to school? Put on the smart board?
It's embarrassing.
Put on the smart board? Who'd you go with?
Got this job.
Go with the dad?
Do this one.
Of course he did.
Nope. some other shit. Yes, believe it or not, I didn't. Yes, I actually, at some point in my life, I was really 15. There was a point in my life that I was, in driver's ed.
What was your first car?
1989 Ford Escort EXP two-door hatchback.
Teachers don't have lives.
Pretty awesome.
As Calvin said, the sequels always thought that teachers slept in coffins. And
What do we do, guys?
basements.
You do 3. Did you get X equals 4? Under both of those, and then you just solve that equation. Then you get X equals 5.
I have no idea.
Oh my god! I did it already. Me and Dave did it.
Mike. No, not you. Mike.
I'm not listening to you, Derek. Go home, Derek. You're awful, Derek. Derek, you can't even score against Gordon.
Now this is about as weird as this stuff gets.
Oh!
One thing I want you to notice the difference between this problem and the ones we've done before is notice how there are multiple logs on one side. Since what happens here is you have to use your rules of condensing before you do anything. What you have to do is condense it to a singular log before you can exponentiate anything. Whoa. What does, when you're adding two logs together to have the same base, you're multiplying, okay? So what I want you to do is think of it like this. It's log of 5x times x minus 1 equals 2. How do I get rid of the log? I exponentiate it with a 10. So now I get 5x squared minus 5x is 100. Is everybody okay with that?
Yeah.
Good. And the first rule of factoring is to always look for the GCF. Which one's which?
-5 and +4.
So your solutions are?
But are they?
But are they? Exactly. So now you just have to take those two solutions. You got to check it with 5 and -4. You're just going to substitute in to see if they, but at one at a time, okay? Not with both of them, it's different x values.
Are you like trying to rappers?
So you just double check with your solution here to see which one of them works. If either of them work. If none of them work. And that's what we're looking at doing here, guys. Come on, guys. The -4 here isn't going to work, so your only solution here is possible. Is 5. If you substitute through. Okay. Again, when you get to this point after you factored stuff out, it's really quick and easy just to go ahead and substitute in and just press the buttons on the calculator. Just verify which one works. Okay? All right. There's one other one I wanted to look at real quick.
Who was that? Mr. Murphy, it needed that word. Because it
Some
was
kid
crazy.
aged his ear in our health class. And
There's
it was
blood
bleeding
everywhere.
all over them.
And he put in like this crystal, it was really wide at the bottom, and it got
He
short.
just
And he
his
put it
ear.
in his ear like
In
as
our
an
health
earring.
class.
Like an ice cream cone with
Yeah.
Some kid.
Don't you want to sometimes just go over like a padlock and just kind of go like that and walk away?
Now I do.
That's funny. That's hilarious.
That's a good idea.
That's
That's a
so
good
much getting
idea.
trouble
That's
with that.
So give me some, let me give you some problems.
Why not just tell us what you had there?
There are, all right. I have no qualms if that's what you want to do with your ears and all that, but just think about what you're going to look like when you're 50.
Yeah.
I would never do that to my ears.
Wait, what's the game?
It's kind of ironic, isn't it, Mister? Some people like gauge his ears in.
Well, you like go up. You start out small.
Yeah.
That's true.
But like,
Just a quick refresher here. Those last 3 problems deal with your exponential growth, exponential decay, continuous compounding, or a compounding quarterly or semi-annually problem, which means you may have to go back to revisit those equations. You will be using and solving for a part of those equations using logarithms and all that kind of mumbo jumbo. Yeah, this is all of them. This is still the section 8.6. There is absolutely, positively no reason for you not to get this done over the next 20 minutes. 25 minutes.
Company that gives you this paper.